Okay, hey everybody. So let's try and solve some non-homogeneous equations. Once doing the method of undetermined coefficients, right? And then the other time, I'm going to do the exact same equation, but using variation of parameters. So let's start off with something nice looking. We have y double prime plus 25y is equal to x cosine of 5x. Okay. Now, as we're all aware, the very first step is to solve the homogeneous version of this, right? Solve homogeneous version. Okay, so that's going to be y double prime plus 25y is equal to 0 instead, right? We get our characteristic equation, so we get r squared plus, well, there's no y prime term, so 0r plus 25r to the 0 power, right, is equal to 0. Okay. And then now I got to find the roots of this, right? And while you could use the quadratic formula or whatever, right? This is the same thing as r squared equals negative 25. So then we get r is equal to the square root of negative 25, which is just plus or minus 5i, right? Now I'm going to rewrite this in the form 0 plus or minus 5i. So we can see that our alpha is 0 and our beta is 5 over here, right? So then our first solution, y1 of x, will be e to the 0x, which is just 1, cosine of beta x, so cosine of 5x. Y2 of x will be e to the alpha x, which is b e to the 0x, which is 1, right? Sine of beta x, that's sine of 5x. Okay, so now we have our homogeneous solutions. And then now the general homogeneous solution will just be a linear combination of those. So we get c1 cosine of 5x plus c2 sine of 5x. Let's pause here for a second. Okay, so now that we've solved that homogeneous version here, now we can go on to step 2, which is to try to find the form of our particular solution here, right? So this right over here, oops, this right over here, I like to call f of x. Okay, so that's our f of x right there. So I'm going to copy that back down over here. So f of x is equal to x times cosine of 5x, right? And there's a polynomial part, which is great. Okay, and there's also a cosine or sine part. In this case, it's cosine, which is great. Okay, but there's no exponential part to it. So I would like to insert an exponential part. I'll insert e to the 0x, which I can do because e to the 0x is just 1. So it's just x times 1 times cosine of 5x. So it's equivalent to what we started with. Okay, now I'm going to write down what our m, alpha, and beta, and k are. Our m is a degree of the polynomial part of f of x, the degree of the polynomial. So this is x to the first power, so our degree there is 1. Okay. Our alpha is the constant that is in the exponent of e. So our alpha is 0 in this case. Our beta is going to be the constant that's on the inside of either sine or cosine. So in this case, our beta is 5. Okay. And then now k is the number of times that alpha plus beta I is a root to the characteristic equation. Okay. So this alpha and this beta that we just found here, the number of times that that's a root to the characteristic equation. So in our case here, right, I'm just going to write it out. It's the number of times that, well, alpha plus beta I, that's 0 plus 5i. So the number of times that 5i is a root to the characteristic equation. Okay. So if I look at my roots of my characteristic equation, I have two distinct complex roots here. I have that R1 is 5i and R2 is negative 5i. But only one of these is equal to 5i, right? So then I have that the number of times that 5i is a root is exactly once. Okay? Yeah, only one times. Is negative 5i a root? Yeah, but negative 5i is not equal to 5i. Those are two completely different roots, right? So 5i is only a root one time. Okay? Now we go on to our set of associated functions, which I'll write it out in general here first. It's x to the k power, e to the alpha x, cosine of beta x, right? All the way up to x to the k plus m, e to the alpha x, cosine of beta x, right? Just multiplying by x a whole bunch of times until we have m plus 1 cosine functions, and we get the exact same sine function. So x to the k, e to the alpha x, sine of beta x instead, all the way out to x to the k plus, ooh, I don't know what happened there. X to the k plus m, e to the alpha x, sine of beta x. So plugging in my parameters here, my k is 1, so we're going to start off at x to the first power. Our alpha is 0, I believe. So e to the 0x is just 1, so I don't have to put that in there. And so now we have cosine of beta x, so that's cosine of 5x. That's my first term there, right? My m is 1, so I'm only going to get one additional function after this, right? So I'm going to multiply by x one time. We get x squared cosine of 5x. Remember, you always have m plus 1 cosine terms, just like I have here. Okay. And then now we get the exact same sine term, so you don't even need to think about it. X sine of 5x, x squared sine of 5x. Okay. So that's our set of associated functions, which means that our particular solution, y sub p of x, I'll just use a, b, c, and d. We have a times x cosine of 5x plus b times x squared cosine of 5x plus c times x sine of 5x plus d times x squared sine of 5x. That's the form of my particular solution, right? So now I got to take derivative of this and I got to plug it back in to find the undetermined coefficients here, a, b, c, and d. All right. I just might have to wait till the next part of this video, though. So how do I stop the recording? There we go.